Hello everyone. Let us continue our discussion on database management systems. So in last class, we discussed about what is a DBMS. Then we understood why it is important with the help of example of library. We understood that if you have a particular storybook, you cannot just go and keep it anywhere you want. You need to keep it in the particular section so that when someone comes and asks you for that book, it is easy for you to give it. So if you're storing data in an organized manner, it is easy for you to retrieve it or access it. Then we discussed about what is a database. Then we understood what are the problems if we are not using databases. And like we discussed the problems with file systems. So this is all we discussed in the last class. So basically, briefly speaking, we discussed that there is something which is helping us to store, organize, and do operations on our data. So it is we just assume that it is something. Now in this lecture, we'll be discussing how it is doing, what is the background happening behind this all process, and how the structure is defined, how it is stored. Basically, we'll unlock the question of how today. So let us begin and let us begin with what is a data model. So before starting with data model, I would like to bring you back to the library example. We discussed that if you have a book, you cannot just go and keep it anywhere. So think of the factors which are affecting the position of book. So you can think of the author's name, then book title, genre, or anything which you can decide to categorize the book. So these parameters define how where the book will be placed. So there should be some structure which defines how the storage is going to be happening. So this is what exactly data model does. Data model provides a structure for data. It defines like it will tell how to store data, in which fashion we have to store data. So it helps in organizing, storing, and retrieving data efficiently. We've discussed this before, and the very important question which may come to your mind is, okay, data model helps, that's fine. But how do we decide? Like for library system, we have a different kind of decision. For any other system, we'll have different kind of decision. So how do we define? How do we organize data, and how do we define all these things? So there are different kind of data models which exist, and depending upon our requirement, we'll decide one data model and we'll go according to it. So let us discuss all the data models one by one. Let us begin with hierarchical model. So um, can you think of your family tree, like from your grandparents to your parents? Think of your family tree where each person is a parent but can have multiple children. Okay. So think of your grandparent. They can have multiple children like your parents. Then comes you. Okay. So is this a kind of structure you can imagine? So we know that this structure is known as tree. Like if you know about data structures, this is a tree data structure. So this is how the pattern look like. So we can say that there is one parent and the parent is having multiple children. No children can have multiple parents here. Only each children can have only single parent. So this is what happens exactly in hierarchical model. Here we are treating mm, just okay. So here we are organizing data in form of tree structure where we are using parent child format to store the data. Okay, so each, as we discussed now, each child has only one parent, and but parent can have multiple children. So this is used in kind of file systems, then organizing charts and early DBMS like IBM and IMS. So these were used. Uh, so let us think of some examples and understand this in much detail. Can you think of file system in your computer? Like if you know there are some directories, then in that directories there are some folders. In that folders there will be some files. So is this how the system looks like? There is some major directory, then folder will have some documents. So can you see there is some kind of hierarchical the structure? There is some kind of tree structure in this. that drive, this is your directory, C drive. Drive is having folder and file as two children. File is having children as document, and file is having folder is having children as document, and file is having its children as note.docs. So this is how the structure of direct file directory system will look like. Let's take one more example. Uh, can you think of your university? Like your college must be a part of a university. Then you have a few departments in it, such as there is one computer science department, there will be another electrical department, one mechanical department. So there'll be many departments into your university. And then again, each department will have a particular number of professors and particular number of students. So it will look like university is a parent, then you'll have departments, and then you will have professors and students. So again, this also follows a tree structure. So these are the examples of hierarchical model. I hope you're clear with it, and let's begin with the next one, which is network model. Now in hierarchical model, if you can see, there was only one path from one particular node to other. Let's say if I want to go from this node to this node, this is the only path which I can follow, but there is no other option. Now imagine if you're standing on a railway station. So if you want to go from station A to station B, is there only one path which you can take? No, right? You have multiple options. So if this is kind of structure, you can go from here, then you can go from here, or you can directly go here. So there are three possible paths in this particular case. So in real world, there are multiple paths which are possible for reaching from one node to other node. So network data model exactly takes care of this particular scenario, and where we follow a graph like structure. If you know about data structures, this is a graph data structure. So the graph like structure is maintained, and where we can have many to many relationships. Like this node can be related with many nodes, and then again this nodes can be related with many nodes. So here a many to many relationship is followed. So as we discussed, think of a transportation map. A single train station node connects multiple routes, and each route has multiple stops. So if we are considering a hierarchical model, it is not possible to visualize this scenario. So for this particular cases, we can use network model where we have a graph-like structure. So as we discussed, it supports many to many relationship. Like one child can have multiple parents. Note that this was the only thing which was not there in hierarchical model. Like there every child was having single parent, but now here we have one child can have multiple parents. It is more flexible than hierarchical model because we are able to accommodate the extra feature that we can have multiple paths from one node to other. So it is much more flexible. Now think of the examples where this can be used. So this is used in banking, airline reservation systems, then university databases. This is used. Okay. So let us think of the example. So let's if you like again coming back to examples, uh, this is a kind of university system where there are multiple students, and multiple students are enrolled in multiple courses. So student 1 can be enrolled in DBMS, then data structures, operating systems, something like that. Then again student 2 may be enrolled in multiple courses, and each course may have multiple students. C1 may have S1 S2 as students, C2 may have S1 S2 S3 as students. So this can be accommodated easily by network data model. One more example is of, can you think of bank transactions where multiple people do multiple transactions? Okay, so customer can do multiple transaction. One transaction can be done by multiple customers. That is by one transaction is done between two accounts, right? So so that way we this is a many to many relationship. Let's move ahead and talk about relational model. This is the most commonly used model. Before we talk about it, can you think of an Excel sheet? Like, have you ever used an Excel sheet? So in Excel, what happens is you have this kind of structure, like some rows and columns are there. where you have heading for in first row, some headings are there. Then you store data in a form of table. Something like this is there. So can you imagine the situation where you're storing data in form of table? So think of an Excel spreadsheet where each sheet represents a different type of data. Like consider here customer, their orders, their product ID, like what did they order, their customer ID, and all those details you're storing in form of a table. So this is what we call as relational database. So let us discuss more about it. Relational databases store in form of tables. Again, there is we do not store everything in one particular table. We can what we can do is we can store customer's name, customer's ID in one table, and then we can have another table which is known as sales. And in that sales table, you can have customer ID, then you can have transaction. Again, you can have what product did they buy and all product details. So in customer table, you are just having name and CID. So what you're doing here is you are relating this customer table with sales table, and you are using customer ID to relate. Like you are saying the customer, this customer ID, you go and search in the customer table and you'll find his name. So this is the parameter, like this is the attribute you're using to relate the two tables. And here we call this as foreign key. When we are using a particular unique ID to relate between two tables. And primary key is something which is common, like common identification for that table. Like in sales, we can have sales ID. Then in customer, we have customer ID. So this is a primary key. Again, here it will be a primary key. So primary key is something which is unique, which acts as an identification for that particular table. Okay. So the most commonly used databases, like relational databases, are these. Like I have mentioned few examples. The most commonly used will be MySQL. We'll discuss this in detail in this course. Let us understand about the example again. Let us begin with this particular table. As we discussed in customer table, we are storing customer ID. Note that this is unique. Like there are no duplicates in this, and this is not null. That understand that we cannot have a null value. For null value, by null value I mean that it is not defined. We cannot keep this particular column, no particular entry in this column should be empty. It should have some other value, and this value should not be like duplicate. You need to have it unique. And then yeah, this is what we call as primary key. We discussed about it. Then we have something called as name. Now in name we can have duplicates, that's not an issue. So we have some names, John and Sarah. Then we are having their email IDs. Then we are writing, storing their email IDs. So this is kind of pattern which we follow in relational models, where we are storing in form of table. So keep in mind that in relational model we stored in form of table. Now we'll be discussing about one more model in the next video, which is part 2 of this video.